Okay, students, let's get to work on this again now. So we're looking at more Pascal, and this evening, or this time, what we're going to be looking at is some more data types and uses of data types, and somewhat as to why it's important in how we use the data types, and as a result of which, not using them properly, some likely errors that you're going to encounter. So up in I create a comments area here, which you guys should be fairly familiar with comments now, a multi-line comment. Open curly bracket here, closed curly bracket here. Today we're looking at hard coding data into variables, more uses of data types, particularly dividing by use of div, / and mod. / is dividing. As you know, you can see that sometimes when you have a fraction 3/4 or 3/4. Alright, so you have an idea how that goes. Alright, and mod, modulus division. Now I decided to make a notation here. Div means integer division. That means when you divide, don't matter what remainders may be, the computer is going to show you only the whole number. For example, let us say 17 divided by 3. You're only going to see 5, not the remainder if you're using div. If you use this / here, you'd see 5 point something. Let's say 17 divided by 5. You'd see 5 point something, the remainder. Alright? And the modulus division, you'd only see 2. We're going to put that to the test right now, so you can actually see exactly what we're talking about, first of all. So if you notice, all of these data types, so we have the program name at line 10, dividing data types. Alright, two things we're looking at. Then we are going to look also at num1, the variables, and num2, integer division. And we're going to have a variable called sol, which will contain the solution for whatever that we're calculating, because we have to actually put a container for the answers. Memory allocation, variable, whichever one you want to call it. So here's what we have. Right line, enter a number. We plan to call it num1. So we're kind of giving the user an idea what we're going to be doing. Read line num1. Right line, enter a second number. We're going to call it num2. Read line num2. Then here's what we have. Sol, short for solution. Therefore equals, therefore becomes, whatever it is that num1 is, div num2. Let's put this to the test and see how it works. Let's play this first, or run it. I got an error. This is interesting. What did I leave out now? Let me see. Give me an error. Line 20. Line 20. Where is line 20? Read ln num2. This is interesting. Hold on, let me close this a bit. Not to waste any time, I'll find the error and I'll let you know. Alright? What happened? I think I left a semicolon off here, over this side. Right here, it was missing a semicolon. Alright? So let's go back and run this again. Just sometimes, even when you're writing programs, no matter your level of experience, you will make a little bit of error here and there. So let's call this 17, as we're saying, and the 3. Well, let's run this. So we see we get the solution of the division is 5. Alright, full stop. So 5. You see, no remainder. Now look what happens if we were going to do this. Let's substitute this now and put a /. Notice that's all we're changing. Run the program. We are expected to get some errors. Why? Because this now is floating point division and this is declared as integer. So now we have to change this and call it real. Oops, real. Can't even spell real again. Alright, so now we call this real. Alright, and we might, since we know it's real, a floating point number, alright, or decimal number, let us format it. 0 spaces, colon, 1 space. So colon, 0 spaces, colon, 1 decimal point. So let's run this now and see what happens. That should solve our problem. So the program runs just fine just by changing sol to real. And then let's put 17 again. And then let's put 3. And now we get the answer of 5.7. Alright, because when we use a forward slash, it means floating point or real data type division. So in other words, you're going to get 5 point something. So sol could no longer be called, as we had it initially, integer. Integer could not work because it will be giving us a decimal number, and this variable is not specified to contain decimal numbers, so it gives us an error. If we're to revert this to a floating point representation or real, and we just run the program now, everything should run as per normal. Enter number 17 and let's use 3, 5.7, we're good to go again. So I hope you're getting a feel of exactly what is happening there. Now, hence proving the point that it's a floating point division. Now let's go to the other point, modulus division. So let us use mod. Mod means remainder division. So when you divide 17 by 3, the whole number you get is 5. But that would be 15. If you subtract 15 from 17, you get 2. So modulus division should give us a value of 2. So we can change this back to integer if we wish. Integer. And oh, we need to remove this as well, because we don't format integer numbers, only floating point numbers or real data type. Run this again. We shouldn't have any errors. We didn't. And let us type 17 and 3. The answer we get is 2, because the last number you can divide by 3, the highest number, is 15 without leaving a remainder, right? When you subtract that 15 from 17, the remainder is 2. That is why I got 2 as the answer. Alright, so that is basically how it works for modulus division, remainder division. Notice, let me exit out of this first. Let me exit out of this. Come back here. Let me change this to back to real. Let's mess around with this. We have done the task we set out to do. So let's set that at real and then run this. Let's run it and see what happens. The program works. 17 and 3, and we get the scientific notation 2 something, whatever scientific notation, but we mean 2 because modulus division, right? However, let us format this now, colon 0 colon, let's say 3. Let's mess around a bit. Let's say 3 decimal numbers. Bring this back up. Alright, run the code. Let's run the code. Alright, and we have 17 here, and let's go 3 again. 2.000. Make sense? Good. Alright, let's continue a bit. Now let us change this back now to integer, because we are going to get a whole number, so why not just have it as integer? Let's run that and see what blunders we will make. Problem. Alright, because we are trying to format a not a floating point, sorry, an integer, a whole number. We don't format whole numbers, only floating point or real characters. So we remove that. Program runs again just fine. Alright, 17. Let's try another number. Let's mess around a bit. Let's say we say 23, and we are going to say divide by 7. Alright, remainder 2. Why? Because you should figure that out by now, right? 3 times 7 is 21. Make sense? So 21 from 23 is 2. Remainder division. So that is how that works. So we could actually hard code this in by doing this. We didn't have to go to all of that. We could simply say here num1 colon equal to Let us use something. Let's say 30. Oops, 30, but semicolon. And let's say num2, let's hard code that in, colon equal there. So num2 therefore becomes, let us see now, let us say 7, semicolon. And then now we can get to work. We don't have to no longer have to interact with the program. Just run and see what happens. The answer is 2. Alright? This is what we call hard coding, where it doesn't require user interaction. The computer just work with the number that is given. Then we go again and we say here real or floating point division, but now we have to change sol to a floating point data type. If you run this as is, we're going to get an error. So all we have to do is go back here and change this to real and run the program again. That should fix our woes. And here we have 4.2 something. Alright, which makes sense, yeah? Because 7 into 30 would be 4 7 28 plus some remainders. Alright, and we can do the final one now, saying this is now div. So this will now become a, again, whole number, integer division. Alright, go dividing, and let us see what happens. We shouldn't get an error. We shouldn't. Keep our fingers, our toes crossed, and here we have the number 4. It does not give us a remainder, remember, integer division. But now if we want to get the actual number without the scientific notation, we can go here and then we can set it to integer, run it. That should work just fine. Get 4. Or if we wanted to keep the real, we could do that, keep real, and then change this to colon 0 spaces colon no decimal place. Alright, and then when we run this now, we get the same answer as if it were an integer 4. So that is basically how that would work, guys. So you can go through the video, play it as many times as you feel like, because this is the reality of it. How you declare your data or your variables will determine, in many cases, the errors that you can get. Remember, div, integer division, / floating point division, but you have to declare your variable as real. Mod is remainder division, and you can also again declare your variable as integer because it will be a whole number. And if you want to work around that, we give you the examples and the scenarios of how exactly you'd get that done.